At 2:14 a.m., the BAS rebooted 3 times in 10 minutes, and the on-call tech swore it was a firmware bug, until a power logger showed voltage spikes every time the passenger elevator started. Welcome to Built, Wired, and Secured. I'm Alex Morgan. Today we're pulling apart those moments when electronics look broken, but the real problem lives in the power.
Right away, that paints the picture. Tenants call, security blips, and you end up chasing firmware or firmware vendors while the electrical issue quietly keeps happening. From an operational standpoint, it's the timing and correlation that give it away.
Totally. I remember a site where chillers drifted on humid afternoons. Controllers blamed software updates. We tracked it down to harmonic distortion from newly installed VFDs on a rooftop pump bank.
Wait, hold that thought for a second. What actually tipped you off to the VFDs as the culprit?
We saw the pattern, drift only during peak load on the pumps, and a portable log showed elevated harmonic content coinciding with those runs. The numbers matched the equipment change window. Preventative maintenance beats emergency repairs every time. So once we had the data, the fix was obvious.
That moment, data changing the story, is exactly why owners need to think about power health, not just, do we have a generator? Why does power quality deserve a seat at the table with IT and facilities?
Because power quality affects uptime and asset life without always tripping breakers. You can have continuous voltage, but still see controllers glitch, UPS batteries cycling more often, access systems drop for seconds, the stuff tenants notice first. The question I ask teams is, what breaks if this goes down? That helps prioritize.
Right, and the invisible costs, battery replacements, shortened controller lifetimes, are real line items over time.
Exactly. Documented nuisance alarms are another red flag. When alarms keep firing with no root cause identified, that's the kind of pattern I want to instrument for.
Okay, let's walk through typical causes. Michael, short list. What are your usual suspects when you walk into a mechanical room?
Non-linear loads top the list. VFDs, modern LED drivers, racks of server power supplies. They inject harmonics. Then you have grounding and bonding problems, loose lugs, mixed neutrals, or missing equipotential connections that let stray currents do mischief. Finally, UPS generator interactions. Poor transfer settings or mismatched impedance can produce sags or transients during transfers.
And installation choices. Undersized feeders, long neutral runs, panels loaded asymmetrically. They might not trip anything today, but they elevate temperature and stress. In one building, a mistied neutral created a ground loop that made sensors drift, maddening because it read like a calibration fault.
So if I'm the on-call tech or the facilities manager logging the issue, what should I note before bringing in a consultant? What turns do you want me to document?
Timing and correlation. Does it happen when a big load switches on? During generator tests? Is it sub-second blips or sustained sags? Short transients point to switching noise. Repeated brief outages suggest harmonics or grounding. Also, ask who is affected. If BAS and security hiccup together, check common electrical paths.
Start local. Isolate which breakers or racks are involved. If it looks widespread, a portable power quality logger for 48 to 72 hours is your cheapest diagnostic. It will show harmonics, sags, and transients, way less disruptive than opening panels blindly.
Monitoring first, got it. But when the data points to a real issue, who should own the remediation? Facilities, IT, an external electrical engineer?
Ownership should be pragmatic. Facilities own feeders, panels, and grounding, so they should lead scoping and low-cost fixes. IT must be fully engaged because their equipment is most sensitive and their logs help the diagnosis. For design-level conditioning, bring in a qualified electrical engineer, but make that a measured escalation, not the first line of spend.
Hang on, some facilities leaders worry they'll be on the hook if they delay calling an engineer. Won't pushing diagnostics in-house expose owners to liability if something's missed?
Good pushback. The approach isn't do it yourself and hope. It's do low-risk, high-value diagnostics first. Loggers, visual grounding checks, UPS health tests. Then use that data to justify engineering scope. That actually reduces liability because your decisions are evidence-based, not guesses. And contractually, you should document that you performed measured diagnostics and engaged an engineer when data indicated capital work was needed.
Right. Phase the work. Phase 1, monitor and maintain. Phase 2, targeted suppression or filtered UPS. Phase 3, capital rework if the data supports it. Small wins give you time and budget justification for the big moves.
Let's get tactical. If I had to start this month, top 3 actions?
1. Deploy a portable power logger on circuits feeding BAS, security, and critical IT for 48 to 72 hours. 2. Run a UPS health check, battery condition, runtime, firmware, and alarm history. 3. Do a visual grounding and bonding audit. Loose lugs or mixed neutrals are surprisingly common.
Add selective surge suppression at panels where you see transients, and standardize PM tasks for VFDs in UPSs, thermography, torque checks, and scheduled battery replacement. Preventative maintenance beats emergency repairs every time.
When does the work need to escalate to conditioning, filters, or dedicated feeders?
Escalate when monitoring shows sustained harmonic distortion above recommended limits, or when operations costs and shortened equipment life make capital defensible. Conditioning can be expensive, so use measured data to build the business case. Often, a targeted active filter on one feeder solves the problem at a fraction of rewiring costs.
But watch for trade-offs. Filters can change behavior during generator transfers, and conditioning can mask a wiring issue that still causes heat. Always pair a capital fix with a verification plan and update your maintenance schedule accordingly.
Give us 2 quick real examples, one small and one big, that show the range of outcomes.
Small, downtown office where access control lost sync during elevator starts. A short logger deployment showed spikes at those moments. Localized surge suppression at the door controller panel fixed it with minimal downtime and low cost.
Large, a medical campus with persistent UPS failures. Monitoring revealed harmonics from imaging suites. They installed active harmonic filters and rebalanced feeders. A capital project, yes, but the lifecycle savings and uptime improvement paid back the decision. Reliability starts with disciplined maintenance, and sometimes you need the right capital work to support long-term reliability.
30 days. Deploy a power logger on critical feeders and run UPS health checks. 90 days. Analyze the data. Perform a grounding visual audit, and add selective surge suppression where transients show up. 180 days. Use the evidence to scope any conditioning or feeder work and include it in your capital plan if justified.
And document everything. Timestamps, tenant activities, load changes. Context turns numbers into decisions. Trust the process. Monitor, maintain, then remediate.
For listeners who want a starter kit, GDS Technology put together a 1-page power quality checklist and a 5-point monitoring template that shows logger placement and basic thresholds to watch. You can download both from the show notes.
If teams take one thing from this episode, present power is not always healthy power. Ask, what breaks if this goes down? And let that guide your priorities.
And remember, preventative maintenance and measured instrumentation are the highest return plays. The best day in operations is the one nobody notices.
Thanks, Michael. Thanks, James. This was packed with practical steps facilities and IT teams can use right away. Thanks for spending a few minutes with us. Built to last, wired with intention, secured for the real world.